Alrighty, why don't we get started? So, any questions about anything so far? What's up?
So I emailed you about the date class. It's so cool.
The date class?
Like the you had to like it was like one you said 2 1 exercises.
Mhm.
Like, I was just trying to get it.
Yeah, there's one assignment that the date one. There's a date class and there's a use date.
I have both of those. So every time I try to apply either one, I get the same.
Okay, I gotta look at it then.
Right.
I'll look at it after. Did you figure out the packages?
I put them like in the order, and then I try to run them.
In what order though? Because you emailed me the files and they're all just files, but I didn't see any folders.
They need to be just like in folder 1.
Yeah.
2. Okay.
Just like I have it in the picture.
Okay. So the first folder is going to be folder 1, and then I put folder 4 and folder 1.
Right. So look at this thing here. So I'm gonna download this. And there's a reason I put this in here, and because one student, he's trying to do the Oracle certified programmer or whatever, and I have all the materials that he sent me, and well, one of the things that I'm not covering, or I mean the book talks about it, but they don't really give you any examples of packages. They just mentioned that the package is just a bunch of Java files in a folder, right? That's it. Okay, well, package is a Java class file in a folder. Okay, so this is just a quick little thing here. Let me zoom in on this. So this is your folder structure. Doesn't matter. I have it in some folder called package tests. Inside the package tests, there's this runner, right? So this one is not inside any of the other folders, right? This is the runner is going to run all these other ones, right? And there is a folder called 1. Inside the folder 1, there's a file called 1 Java. Then there's a folder 2. Inside the folder 2, there's a 2.java, and the 4, there's a 4.java, right? Folder 4 is inside folder 1. Folder 2 is inside folder 4. So this one's inside this one, which is inside this one. This one's outside of all these other. Is outside of all these. Okay. Huh?
Those are the first package tests.
Okay, so look at the packages. So the packages are, we have. Let me zoom out a little bit. Talking about packages. Okay, so package, and the packages, they kind of follow the folder structure, right? So this is package 1 because there's a folder 1, right? So first of all, the runner, in order for my runner to have access to this file here, we're talking about the class file, right? Because, yeah, right after we compile for Java, we get the for class. Okay, so in order for my runner to have access to for that class, I have to import 1.4.*, right? So that imports everything inside my folder. In order for my runner class to have access to 1.java, then this is my package 1, right? So package 1 is just basically inside this folder, and that's it. So in here I say import 1.1. So 1 is the package name, right? .1 is the name of my class or the Java file. Question?
Yeah, a couple questions. I did this yesterday, and to get it to work, I had to compile each
Yep.
.java separately.
Yep.
Like a command you can do to say go all the way down and compile every Java.
There
So
is.
you don't have to do it every time for each
Huh?
separate file.
There's a tool called Java ANT, A-N-T.
Oh, that's right.
That's what I was mentioning to you yesterday. Yeah. So, yeah, you could write a script for if it's a Linux file, you can tell it go through this and compile all. But no, there are tools within Java that will allow you to do this, because there's monster projects with lots of files in these kind of folder structures, and you don't want to go there and manually compile everything.
Yeah, yeah.
But I'm not getting into that just yet.
Okay.
Okay.
Another question was,
Yeah.
if you look at the render.java,
Yeah.
import 1.4.star and import 1.4.2.star.
Yep.
I mean, why can't we just have 1.4.star and that includes everything under it? instead of
Try it.
have to do-
Try it. It doesn't work.
No, it doesn't.
Exactly.
No, that's
It's just
how it
wait.
is.
Well, yeah, that's just the way it is.
Directory, not like from
Yep.
all the way down.
Yeah, you cannot tell it, and that's why I put some comments in there that basically if you say, that's the reason why I did it this way. So if I say 1.4.*, this does not import any other subfolders. So when I say 1.4.*, that is going to include anything that's inside my 4 folder. I mean, any Java file, but it does not automatically include the 2 folder. That's what this is. That's what this tells you. So import all class S from package 1.4. It does not import anything in package 1.4.2.3. Right? Right. I renamed it. This one right here. This used to be 2.3. Okay. So if I say import 1.4, this does not import this particular folder. In order for you to import this folder, you have to say 1.4.2. Then asterisk. Right? And the folder structure makes a difference. Huh?
Is this Eclipse?
No, this is not Eclipse. This is just the command line. Yeah, how you do this thing from scratch. So yeah, I have a structure, a folder structure in here. Files are spread all over the place, and I have an example in there for you so you can see it. And then there's an assignment, and I even give you the answer for the assignment. But you have to compile them in this folder structure, otherwise it's not going to work.
And then run them all, and then
Yeah.
run.
Yep. Question?
Can I do this in Eclipse just like that?
You could do it in Eclipse, yeah, but you're gonna have to create. I would prefer it if you don't do it in Eclipse, because that Java certification thing from Oracle, they probably are not relying on any particular IDE. They want you to know how it works without any aids, and this is how it works without an IDE. Okay.
You want us to start using Eclipse from now on for this?
Sure. Yeah. I mean, except this one. For this one, I wouldn't recommend Eclipse. Just try to do it. Organize things in their own folders, compile them, see what a pain in the ass it is to compile 50 different files separately, and then maybe I'll show you at some point Java and that is the tool that allows you to compile different things, other than writing a script. Yeah.
Also, this is very specific to this hierarchy. Like if you move a file somewhere else, it doesn't
Yep.
work anymore, right?
Yep. If you for some reason move things around, the package structure is not going to work. You have to change the package based on where the file is located. Yes? So there you go, Java packages, something that wasn't part of this class, but now thanks to you it is.
One last, so runner
Yeah.
class and read class, they're in the folder of
Which one?
the runner class
Yeah?
and the read class. Those are in the first folder, right?
Let me show you.
I was in the yeah.
Fall 2017-24 package tests. That's the folder structure.
Okay.
All right, so if I collapse this little thing here, yeah, runner is outside of all the other ones. Then there's your 1, there's the 4. Inside 1, there's only 1.java. Inside 4, there is 4.java. Inside 2, we got, there's a 5 in there too. That's for the assignment later. Yeah, so this is the one you're supposed to add for your assignment. But I give the answer for that too. Okay. Other thing is, last time I kind of mentioned Bash, and this is what it looks like on a Mac. All right, for Windows it's slightly different. For Windows it kind of works easier. For Mac, you have to change the permissions for a file. All right, so first of all, this is if you want to compile and run something with one command. So this is a file called compile.bat, right? And let's say I'm trying to compile a file called filename.java. So I create this text file. By the way, these are comments. This is how you do comments in a script. Yeah, so anything with a pound is a comment, just like Python. First thing I do is I change my batch file to be an executable file. Otherwise, I can't run it. Then after that, so this piece right here changes compile bat to make it an executable file. Then this piece right here runs the file. So if you do // that is how you tell in Linux or Unix in the command line to run a specific executable. You can only run executable files, which is why I had to change this permission right here to add an executable. And that's it. So you just say // compile.bat, some file name, and then it compiles and it runs it. just like you would in Windows. Okay, in case you want it. But since we're kind of starting with Eclipse, or we already kind of started with Eclipse, so you don't have to worry about that too much. But it's another tool. All right, so that's that. And what we're going to talk about today is repetition. If Canvas ever opens,
Canvas won't open.
it wouldn't open for you, huh? Okay, yeah, I'm not surprised. Canvas sucks. Courses 24. Yeah, I had students telling me like, yeah, I can't see the file. I'm attaching files to like student submissions, and they can't see the files.
That, swapping that 1.4 that you just went over now.
5.4.
Yeah, because I was just looking at that. Because I was doing chapter 5 last week and I did not see that later.
It's in which one? So 5.4. No, that's not it. Which one? The swapping. That was that chapter 4.
The one you were just going over right now.
The packages.
Yes.
I changed it. So if you have already started working on things from the old assignment and you turned it in, I gave it full credit. If you turn in something else other than packages, no worries, I'll let it slide. But if you want to do the packages, I highly recommend it. If you haven't started doing the previous thing that was shown in there, yeah, you can use the dates, and yeah, that's fine too. I'll take it. Okay, but it might be actually more beneficial to you to do the packages business. But I'll help you do the dates too. If you want to turn in both, that's good. All right, so that was week 5. Week 5 talked about selection, and now we're going to talk about repetition. And repetition, same thing that you've done in other languages. If you've done other languages, it's exactly the same like C++, because Java is a whole lot similar to C++. And loops are slightly different in Java than they were in Python. But yeah, you get the hang of them. They're not that hard. Okay, so first let me just go through this book thingy, the summary that I have. And I haven't updated these assignments just yet for week 6, chapter 6, but I will, right? So my goal is by the end of this semester just phase out the book and not have to have a book for this class. Huh? Yeah, sell your eBay. All right, so different kinds of loops. We have a while, we have a for, and we have a do while, just like C++. Python did not have a do while, but you'll see it. Yeah, so just some examples in here. What the break is, how it works. All right, so I'll go over that. So what I'm going to do is fire up Eclipse because I want to make my life easier.
Oxygen is the latest one.
I think that's the latest one, yeah. Yeah, they keep renaming them. Okay, so I am in CSS 24. I'm going to create the project. First of all, let me see the default package. What's in it? Okay, I'm going to right-click, new class. All right, and I'm going to call this thing loops. All right, loops. If I wanted Eclipse to create a main for me, I can just click this public static void main, and then if I say finish, then it creates the class for me. Okay, and it automatically makes it a public class, but I'm going to get rid of that piece, right? Because it's going to be a standalone class that is not going to be accessed by any other class. So there you go. First thing you should always do whenever you create a project is get some output out of it. System out println hello. All right. Okay. So first of all, if you see this little triangle here, see this little triangle? That means that, from what I've noticed, Eclipse recognizes that there's this file name, loops.java, which is loops, which is saved inside of a file called loops.java. Okay. If I change this thing to like loops example, you notice what happened with the triangle? It went away. All All right, so okay, so what's going to happen is, let's say I don't have, this is loops.java, right? I'm going to run this thing without doing anything. So if the name of your class is saved in a file that has the same name as your class, then you can just run the thing. Whatever. All right, there's your hello. Okay, and I'm going to change this thing now. And I'm going to say this now, this is loops example. I'm going to try to run this thing again. Proceed. Can't find or load main class loops. Okay, so basically Eclipse thinks that you're trying to run a loops.java file, but I want you to have by default the thing inside of a class called loops. So you can still run it. You have to click this little thing right here. All right, you have to the little play button. Next to the little play button, there's a drop down arrow. You click that, you go to Run Configurations, right? And in here you can say, okay, hold on. It's assuming that the main class should be inside loops.java because I'm working with loops class, which should be inside of the loops.java, but it isn't, right? But the name of my class is loops example. So that's not the name of my main class. I'm going to click this, search, and I'm going to tell it where to find that thing. Right? These are the different classes in the project. I want the loops example. That's the name of my class. So I need to tell Eclipse where the main is saved, which is right here. So I hit OK, I hit apply, I hit run, and then ignore this thing, and there it is. Now it runs. Okay, so you got to do a little jumping through the hoops to get this thing going, which is why from the beginning of the class I was recommending to always save your file names, or your file name should match your class name. Okay, if that's the case, then you don't have to worry about it. Okay, now I might complain because, oh, there you go, it's still working. Okay, so there it is. Now let's do some loops.
So you don't do a package for each?
No, yeah, I don't do packages, but now you know how to do packages with that assignment. Okay, so first thing I'm going to do is I'm just going to go in there. I'm going to copy some of these things. Java util. All right, we need Java util for the scanner, which I'm going to be using. All right, here's my scanner. All right, and for using the scanner class, we don't need to handle any exceptions. And throw that in there. Okay, so first of all, I'm not even going to do this for now. Okay, the first thing I'm going to do is, all right, so we have my little hello message. I want that message to repeat a couple of times, right? So instead of me going in there and copying, pasting this thing a bunch of times, all right, what I want to do is I want my program to repeat it 5 times for me. So first, let me test. And I always launch without asking. And I got a bunch of hellos in there. Okay? But now what I want to do is I want to write a loop. Okay? Want to make the above hello, above message appear 5 times without copy pasting it. So it goes like this: for int I is equal to 0, I is less than 5, and then I plus plus, curly brackets. I'm going to grab this thing, copy it, paste it, run that thing, and here it is, 5 times. In case you're wondering, let me make this a question mark. And yeah, the question mark gets repeated 5 times. Okay, so the way a for loop works, is you have a start, you have a stop, and then you have a step. Okay, so we're telling this thing you're going to start at 0. We're telling it you're going to stop at 5, and we're telling it you're going to increase your value by +1. Right? So I plus plus, right, is the same as I plus equals 1, which is the same as I is equal to I plus 1. right? Which is how we increase the value of something by +1. So what we're telling it, what we're actually telling it here is we're basically telling it I is going to have the values of 0, 1, 2, 3, 4. And that's it. It stops at 4. If I wanted to go all the way to 5, I can make this thing less than or equal to 5. In that case, it will go to 5, right? 5. But that's not what I have. I'll have it like this. And I can show you the value of I instead of hello. I'm going to take this out. And I'm going to do another system out print line. This time it's going to be I equals plus I. Okay, I'm going to run this thing, and these are the values of I. Just like I said, 0 through 4. If I wanted to change this to 5, I can do equals 5. Now it goes to 5. I can also say less than 6. Then it goes to 6. I mean 5 again, right? So let's leave it like the way it was. So this is one way. This is one example of a loop. I is just a variable name. I can call it whatever I want. As long as it's not one of these reserved words, I can use it. So I'm going to go do another one. This time I'm going to call it index. Okay? And by the way, notice one thing. Yeah, I'll call this index. Index. Okay. Notice how it doesn't like I right here. Notice what Eclipse is showing. Right? See how the I is underlined or red, no good, right? The reason why is that? It needs to be indexed, but I defined it here, so why is it complaining about scope? Okay. Very important, right? What's the scope? What is the scope of I? The scope of I is the first for loop. A scope means where can it be used? Where was it declared? So I was declared for this loop, which means it can only be used inside of this loop. If I try to use it in the other loop doesn't know what I is, because I declared it inside this loop, so I can only use it in this loop. Just like if I went in there and I said, well, int A, right? And then I try to use A here.
That's a local variable, right?
That's also a local variable. They're both local.
Yeah. To,
Right.
to what they're.
To the section of the code that they're defined, the segment, right? So what is a local variable, right? Local variable for this for loop can only be used here. Same thing with an I, right? I cannot do an I here. I cannot do an A here, right? Plus, let's do another text. A equals plus A, right? So this is bad. This here, bad, right? I and A are both local to the previous loop. Okay? So make sure you know this stuff and you're comfortable with it. Same thing with I, so I is, all right? I is a local variable also. Same as A below it. Okay, so now going back to the loops business. So I have something called index. So I'm going to be using index as a variable here. And this time what I'm going to do is I'm going to tell the index is equal to. So now what I want to do is I want to show the values of index to be 2, 4, 6, 8. Help me out. How do I fix the loop? Plus 2. So how do I change this to? Index what? Two ways to do it. One is plus equals 2, right? And notice there's no semicolon on the last one. Don't do this. Okay? That's one way to do it. So index plus equals 2, which is the same as index is equal to index plus 2, right? You can write both, one or the other, okay? All right, so I changed the plus 2. Anything else I need to do to make this thing show me 0, 2, 4, 6, 8?
Yeah, change. Where do you go right there?
This?
Yeah.
To what?
Change it to,
9 or 10.
yeah.
Or less than or equal to 8.
You want to go 8? Let's
Less
try
than or
it.
equal to.
Less than or equal to. We can do that. Run it. There you go. 0, 2, 4, 6, 8. Okay. I also heard a 9. Let's try 9. Okay, 9 works. You can also do 10. All right. 10 works. So it doesn't go all the way to the last one unless you make it less than or equal to. I personally would have done it this way. It tells me exactly where it's going to stop. Okay. All right. So this is now you have your start is 0. So let's put a little comment in here. So we have start is equal to 0. We have stop is equal to 8, and then we have step is equal to 2. All right. This is my start. This is my stop. This is my step. All right. So looks like you got this. Let's do another one. So this time it's going to be 4. Let me copy this stuff. Okay, one thing, make sure your indentation is good, right? If I see something like this, I will be very inclined to take some points off. So line things up. Okay, everything in the main is equally indented from the left. If you have a for loop, everything in it is equally indented from the left. I don't want to see this kind of stuff. All right? That is just, it's hard to read. I refuse to read that kind of code. If I see it, I'm taking points off, sending it back to you so you can fix it and resubmit it. Like, it could be perfect solution, but I'm still not going to take it. Yeah.
Because they have a format button.
Do they?
Yeah.
How do you do that? Where's the format button?
You go up to,
Yeah.
I can't see the, I think it's try edit or source.
Edit.
No, go to source.
Where's the source format?
Right there.
But then it might do something I don't want it to. No, it did it. Cool. Oh, that's nice. All right, so for those of you who are identically challenged, whatever the word is, let's try this.
They did a good job with it.
Yeah, that's pretty awesome. All right, tab, source, format. Nice. Okay, yeah, that's pretty neat. I love Eclipse. Eclipse is great.
Which Eclipse is this?
The latest. Oxygen.
Oxygen hasn't been downloaded that much. It's the previous one that I used. Because it's like a beta, I think. But
Yeah.
it still,
Works for me. Yeah, just get yourself one of the latest Eclipses, and the likelihood is that it's going to work fine. Okay, so next thing, and I like how they fixed the zoom in and zoom out. You can finally zoom in and zoom out by pinching and
By doing what?
you can just squeeze and on the trackpad. Okay, so. Okay. Otherwise, it was just a pain for me to change the font in the previous versions. You had to go through the menu, and there's like 50 layers down and deep. Okay, so we got this. Now let's do another one. So this time I want to make a loop. This time what I want to do is I wanted this thing to go backwards. I want it to go 4, 3, 2, 1, 0. What do I do?
Minus.
It's going to be minus. Minus what?
Going back.
Minus works.
Yeah.
Minus works. Okay. Where did I start? 4. And how do I change my stop? My index thing. Greater than or equal to 0. Okay. And then, so let me just change start starts at 4. Stop is 0. step is -1. Okay, so run this thing, and maybe I should put another variable. Let's call it A, so we can tell the difference. A, right? A is 43210. Perfect. Okay, now next thing. Oh, and by the way, if I have a single line of code inside of my loop, curly brackets are optional. So I can go in there, take this out, right? Run this thing again, and it works just the same. Okay? So let me just take this out. So just like C++. So if you have a single statement like this thing on top, the curly brackets are optional. Okay? All right. If you want to put curly brackets around everything, that's fine. In the beginning, when you're learning this stuff, no problem. What else? Okay, so we made it go forward. We made it go in increments of something else. We made it go backwards. Let's change the steps to something else again. So this time, I want this thing to go to, I'll call it B this time. B. Okay, so I want this thing to go 4210. 420, that's it. Okay? Help me out.
Starts
Starts
at 0.
at 4. Still starts at 4. Yeah.
Minus equals.
Minus equals 2. Alright, run this thing. And here's my B. 420. Okay? Okay, one last one is a loop that happens as many times as the user wants to. Right? So this stop and step business, I can get that from the user. But let's just say, alright, here. A loop that happens as many times as the user wants to. Okay? So I'm going to use the scanner thing that I had from earlier. Get all this. Okay, this is going to be my stop. And I'm going to make it an int. And what don't you like? Oh, next. Let's do this. That's why I like Eclipse. sc.next int. There. Okay. So I'm going to get the stop from the user. I'm going to grab that first one that I had. Where is it? This one. Because why not? All right. And then I'm just going to change my 5 to whatever the user wants to. Stop. Okay. Curly brackets. Get this thing here, throw it there, and we gotta change this to I. Alright, run it. 0 or 2 to terminate. Alright, let's change this. How many times to repeat the loop? Run it again. And I want the loop to repeat 5 times. 0, 1, 2, 3, 4. Okay? All right. What else? Next thing is, let's ask the user to enter some numbers and then maybe add them up and stuff like that. Okay, so I'm going to have, so what I want to do is I want to let the user enter numbers. I want to find smallest. I want to find the sum. I want to find the average. Okay, the usual stuff. So I'm going to declare a new variable. I'm going to make it I'm going to call it num. Okay, I'm also going to have a sum sum is going to start at 0. Oh, and another one called smallest. Okay? Let me break it down into separate lines. This, put it there. Okay, so I want to let the user enter numbers, find smallest, sum, average. All right, so instead of here showing this, I'm going to say, please enter a number, and then whatever number it is, and then this, whoops, plus. Okay, so, and then after it, I'm going to do num is equal to sc next int, and let's see how it works. Okay, how many times to repeat the loop? 3 times. All right, please enter numbers 0, 1, 2, 3. All right, so I get to enter 3 numbers. Well, maybe I don't want to start at 0, I want to start at 1. How can I change that? I don't want to see please enter number 0, I want to change I equals 1, and I is less than or equal to stop. All right, try again. How many times to repeat the loop? 4 times. 1, 2, 3, 4. There you go. And I'm going to get rid of the ln because I like to see my numbers entered on the same line. Okay, so now I get to enter 5 things or whatever, however many things the user wants to. That's done. Now, first thing I want to do is I want to start my sum at 0. Right? So sum is equal to 0. Right? To start the sum, start adding. Okay, and then as soon as they enter a number, we're going to say sum is equal to sum plus that number, also known as sum plus equals that number, same thing. All right, and then after that, I'm going to do a system out println, and I'm going to say sum equals plus sum. Okay. See if it works. Test it. How many times to repeat the loop? 3 times. I want 1, 2, 3. Okay, sum is 6. I got that. Average. How am I going to calculate the average? Copy this. Put it there. This is my average. And help me out. What is the average equal to? Sum divided by what? Divided by stop. Right? Stop is how many times this thing is going to happen. What is it really? Because I messed it up. I'm not sure. Let's find out. I kind of changed it, not to say messed it up. So I want 3 numbers. 1, 2, 3. Okay, average is good. Maybe I want to change my these to doubles. I'm going to make these doubles. Double. Then it's going to complain about this here. Next double, and let's try it again. I want 3 numbers. 1, 2, 3. There you go. Now we got doubles. All right, average is correct. 6 divided by 3 is 2. Okay. All right. So now the last one. Last one is finding the smallest. So to find the smallest, I got to give you the idea of how we're going to do this. Right? Also known as the algorithm. So algorithm to find smallest. Okay, first thing we're going to do is we're going to make smallest equal to the first number. Then we're going to compare smallest to all other numbers after the first number. Then we're going to, which is 2a, I guess, 2b. If any other number is smaller than, I guess, 2c, that is your new smallest. Okay? Let me put some dots in here. Dot, dot, dot. Dot, dot, dot. Okay. So basically what I'm saying is this. We're going to have a bunch of numbers like 4, 3, 2, 1. Okay? And what we're going to do is we're going to say smallest is equal to 4 initially. And then what we're going to do is we're going to compare smallest to all the other numbers after the first one. So I'm making smallest equal to the first one initially. Then I'm going to compare if any of these other numbers are smaller. So let's put the 1 in there, and I'm going to put the 2 last. Okay? So first one is I'm going to check to see if smallest is, or if any other number, if 3 is less than my smallest. Is that true?
Yeah.
Yes. Right? So smallest is equal to 3. Okay, then I go to the next one. Now I'm going to compare smallest to 1. Right? So then if 1 is less than my smallest, which it is, right? 1 is less than 3, smallest is equal to 1. Then I go to the next one, which is the last number, the 2. So if 2 is less than my smallest, which it isn't, smallest would have been equal to 2, but it basically stays as 1. So that's what we're going to do. So how do I make smallest equal to the first number? So this is the first thing I'm trying to do. How do I do that?
Yeah,
If what?
if smallest.
If the smallest number, whatever the variable was, is less than.
How do I know it's the first number?
But you gotta set the fourth one.
So my question is, how do I know that num is the first number entered?
Check the first iteration.
How do I check? So first iteration of the loop is when? If I equals 1, right? The first time we go through the loop, I is equal to 1. That tells us that the number that they're going to be entering would be the first number. So I go in there. If my I is equal to 1, that is when I'm going to make smallest equal to that first number. Okay? So this is here. True the first time we go through the loop. And that means here we're making smallest equals the first num entered. Okay? Now the next one was compare smallest to all other numbers after the first number. So that's the next step. I'm going to throw it in there. So how do I know it's I'm going to compare smallest to all the other numbers? When would that happen? When am I going to be looking at all the other numbers?
Can you do a bubble sort?
We're not going to do bubble sort.
Did you define smallest?
I declared smallest right here.
Oh, okay.
Yep.
But could you do that here?
I could, but I'm not going to. Yeah, there's no point for me to yeah, I could sort, but let's not do that. Yeah.
Do an if, an else.
Else, all right? So I do else, and what's true about an else? Else happens
All the other.
automatically when if I is not equal to 1, right? So this happens, right? The else happens for all loop iterations after the first, which is all the other numbers after the first one. All right? And then what did I say I was going to do? I said if any other number is smaller, I'm following my own steps. All right? If any other number is smaller, if any number is less than my smallest, then I make smallest equal to that number. All right? And that's my other step, which is this. All right? And that's it. That's finding smallest. And what don't you like? Initialize variable. Okay, so it doesn't, Java's super picky. It's telling me now that the local variable smallest may not have been initialized. I'm not sure if that's going to be a real bug or it's just Eclipse. Nope.
It did that to me too.
Yeah, unresolved compilation problem. The local variable smallest may not have been initialized. We don't really need to initialize it, but Java thinks that it's best to initialize it, so why don't I initialize it to something, which kind of sucks actually. So if we're talking about the smallest, we want to maybe pick some really big number, like, I don't know, 1 million or something. There's a max int in Java, just like there is in C++. I just don't remember what it is. Okay, but there's within the Java programming language, you can tell, okay, make this thing equal to the biggest thing that an integer can be equal to, or double in this case. Anyway, yeah, so it kind of sucks in this particular example, but whatever. Okay, so that's the error, but then now we're going to go in there, how many times to repeat the loop. I want 4 times. I'm going to do 4, 3, 1, 2, and I didn't show it, which is nice. Let's do that. Alright, smallest is smallest. Run again. 4 numbers, 4, 3, 1, 2, and there you go, we find the smallest. Any questions? And to answer your question why I can't sort is because I haven't introduced arrays yet. We're not doing arrays yet. Okay, so you know how to add a bunch of things, you know how to find the average, how to find the smallest, largest is similar. You're still going to make, if I is equal to 1, largest is going to be equal to some number, and then inside the else you're going to have if any number is greater than largest, then largest is equal to that number. So that's that. So you know how to make a loop repeat as many times as the user wants to. You know how to make them go forward and backwards, and how to change by how much they increase or decrease, where they start, where they stop. So that's pretty much all I want to tell you about for loops. And there's some different formats for the for loops, but I'm sticking with these because this is all in gold. And yeah, that's about as much as I want to tell you about for loops. The next thing I'm going to do is introduce while loops. Okay? So basically everything that you have seen up to this point can be rewritten using a while loop. And I'm going to do it right now. So this is rewrite the above using a while loop. Okay? For the while loop, you're going to have to do a few more lines. So basically, the general rule is, if you know, make it capital, if you know how many times the loop will happen, use a for loop, right? Also, if you know the start, the stop, the step in advance, use a for loop. Okay, it's just neater code, better programming, just better thing to do. Okay, but if you don't, you could use a while loop. And first I'm going to show you how you can use a while loop for everything that we did so far, even though I don't recommend it, because it's more writing of code. So what I'm going to do here is, I'm going to make it capitals. So int start is going to be equal to 0. I want to do that. Yeah. Okay. Int stop is going to be equal to 5, and int step is going to be equal to 1. Okay. So that's the same thing that I did on top, right? I started this thing at 0, went up to 5, or 1 less than 5, in increments by +1. So I'm going to make up some counter variable. Let's call it int counter. Okay, and in counter is going to be equal to start initially. Okay, next thing is I make my loop while my counter is less than my stop. Okay, curly brackets, and then in it I'm going to say counter. I can do plus plus, I can do counter plus equals step, right? I can also do counter is equal to counter plus step. Okay, either way works. But now you can see that this single line right here, line 22 in my for loop, I had to write 1, 2, 3 separate lines of code to basically get the same thing. And to show you that it is the same thing, I'm going to copy this. I'm going to throw this in there, and I'm going to show you counter. Alright, I'm going to run this, go all the way to the top. So this was the values of my 0, 1, 2, 3, 4. That was what this thing did. And you can see that 0, 1, 2, 3, 4, that's the same thing that the loop underneath it did. Okay? So you can write the same thing that you did with a for loop using a while, except it takes a little bit more, 2 more lines of code. Which is why I better practice to do for loop if you can. Alright, so that's this one. Now I'm going to do the same thing for my other ones. So I'm going to grab this thing, and instead of counter, I'll leave this like that. Copy this, paste this here. Forgot this line. Okay, it's complaining because I'm redeclaring these, right? I have already declared them one time. I cannot declare the variables again. So I'm just going to get rid of the declaration part. I'm just going to change them to something else. All right, now the program will work. Okay, so this time I'm trying to do the one on top. So it starts at 0, goes on until it's 8, and it goes in steps by +2. Okay, so counter is still going to start at start, right? It's going to go while it's less than or equal to, just like this thing here. Went on until it was less than or equal to. And instead of counter ++, I'm just going to use this, counter plus equals step. Right? Because this time it's not increasing itself by +1, or it's going to increase by +2. Right? Instead of +2, I'm just saying plus step. Okay? And let's see if that works. I'm going to call this counter 2. Run it. And this is the first one, 0, 1, 2, 0, 2, 4, 6, 8. That's what this thing did. All right, and underneath it, I have 0, 2, 4, 6, 8. That's what this is doing. Okay, so same thing that I could do with a for loop, I can do with a while loop. Go on to the next one. Now, I wanted this thing to go backwards, 4, 3, 2, 1, 0. All right, I'm going to grab this thing, copy it, throw it right here. Okay, and by the way, if the curly brackets for a for loop were optional, they're not optional for a while loop, right? Because it really, at the very least, you're going to need this one line inside of the for loop, but you would need something else beyond that, right? So you will always need curly brackets for a while loop. Okay. So this thing starts at 4. I'm telling it to go on while it's greater than or equal to my stop. It's going to stop at 0, and my step is going to be equal to -1. Right? So I'm going to change this thing to counter minus, which is the same as saying counter is minus equals step, or counter is equal to counter minus step. Okay, and it's going to be my counter 3. So we can tell the difference. Run this thing again. And this is my 8. That's the one on top, right? 4, 3, 2, 1, 0. And this is my counter underneath it, 4, 3, 2, 1, 0. Okay, so that's another way to do it. One more. The last one, well, one of the last ones. Grab this. Alright, so now we want to make it go backwards, but in steps of -2. Alright, I want it to go from 4 to 0. Alright, so this is going to be my counter 4. Instead of minus, I can't do minus because it's not decreasing by 1 every time. I'm going to do minus equals step. Okay, actually it should be plus equals, yeah. Plus equals steps, and step is negative. Okay, I can do it here too. Okay, run again, and yeah, B is 420, which is this, and you have underneath it counter 4 is 420, which is the loop underneath it. Okay, so you should be convinced at this point that everything that I can do with a for loop, I can do with a while loop. And I'm not going to bother rewriting this thing because it's too long. Okay, but I can also rewrite this thing with a while loop, but you shouldn't. Okay, if you can use a for loop, if you know how many times the thing is going to happen, if you know the start and the stop, basically all these different examples that I did, you should do them with a for loop. Don't use a while. Okay, so why would you use a while? Well, the while should be used when you don't know how many times the loop will repeat. Okay, so
Would you usually do a break?
yeah, you would do a break. So let's say, for example, I want to have a loop. Want to have a loop repeat until the user enters, I don't know, 0. Okay, so let's say we're going to have an int n, and the n is equal to -1, right? And I'm going to make a loop while n is not equal to 0, and I'm going to grab, where's this thing here? Get this. Right, and I can tell the user the same thing. Let's say counter is equal to 1 initially. Please enter number counter here. Right, and then this is going to be n, and it's going to be an integer. Okay, so let's see if what it does first. Oh, and I should change counter plus here. Okay, so I go in there, and I gotta enter some things from the other one 0 times. Okay, please enter number 1. That's this here happening, right? So I want 1, 2, 3, 4, 5, 6, 7, 8, 9. When is this loop going to stop? When n is 0, okay, I enter a 0, stops. Okay? Any questions? Did that blow your mind? Wow. Okay. So, another way to do this. Stop. Close this thing. Okay, so another way to do this is we're going to use a break. Alright, so I'm going to grab the whole thing. I'm going to say n is equal to 0 now, right? And I'm going to say while true. Okay, so this here is a never-ending loop. And if you haven't seen a never-ending loop, let me show you one. Print.
It's gonna crash.
Well, we'll find out. All right, so I'm going to run this thing now and watch it go. 0 times 0. All right, so it goes on and goes on and goes on and just keeps writing hellos until it runs out of memory, or or the operating system kills it.
Do you have to even put n to 0, or does it automatically do that?
What's that?
Does n equal 0, does the Java automatically put it to 0?
Yeah, but I changed n from before.
Oh, okay. Oh, I
Yeah.
see.
Yep. Okay, so that's a never-ending loop, right? Goes on forever. It might crash. It should crash eventually. Okay, so what I'm going to do now is I'm going to tell the user, I'm going to copy all this stuff. I'm going to restart my counter again. Counter is equal to 1, just so we can show the same message as before. Okay, and then this time, what I'm going to do is I'm going to say if n is equal to 0. What did you say I do?
Wait, what?
What did you say that I should do if n is equal to 0?
That would be a break.
Break.
Yeah.
Break. Okay, so as soon as you encounter the break, the loop exits / stops here. Let's see if it works. I run this thing, 0 for that other one, All right, so this is 0 for this is the one on top, 0 for that. Okay, now we're doing this one. Please enter number 1. Okay, 1, 2, 3, 4, 0, and then it stops. Okay. Not sure what's going on. Close. Are these all the other ones from before? Yeah, there you go. Okay. So, what else? Let's say I want to do system out println. Hello. Right? Oh, and by the way, let's do another one. If n is equal to 1, I'm going to do a continue. Okay? And what's the purpose of the continue? So break stops the loop. Uh-huh. What's that?
It'll just start the programming again, so please enter the numbers.
Yes. So as soon as you get to a continue, so if the user enters 1, they're going to go to continue, and as soon as they get to the continue, you're going to jump back to the beginning of the loop, and I mean all the way at the condition, check to see if the condition is true, and then, which it is, it's always true, and then continue from the beginning.
What would that be in C++?
Same way.
Continue.
Yeah.
Okay.
Yeah. Yeah. C++ the same. All right. Okay. So then, so this here continue makes the loop resume from the beginning. And by the beginning, again, I mean we're talking about line 153. It goes back to the condition, checks the condition. If the condition is true, then it repeats whatever's in it, in the curly brackets. Okay. So, and again, this is a question I've probably asked before, but when were we going to show this message then? For what values is the hello going to show?
What values?
Yep.
Would be after the loop? After it goes all the way through?
Well, I don't know.
That's right.
If I enter a 0, what happens to the loop? So if like the loop starts from here, right? Is it true? It's true. Okay, we're asking them enter a number. They enter the number. We count it. If the number is 0, we hit the break and we're out of the
Well,
loop.
It's not zero, right? Wouldn't it be if it's false then?
Well, if it's a 1, we hit the continue. As soon as we hit the continue, the loop goes back to the beginning, checks the condition, and resumes everything all over again.
Well, if the condition wasn't true.
You
If
tell.
it's not 0, add not.
If it's not 0 or 1, correct? So if it's a 0, we kill the loop here. If it's a 1, we go back to the beginning of the loop. But for anything else, this message is going to show up. Okay? So this here, the below message shows for any value other than 1 or 0. Okay? So you got to know your breaks, you got to know your continues. Any questions? All right. Yeah. One more. So, one thing is you have not seen this in Python. Is the do while loop. Okay. Do while loop. Okay. And what is a do while loop? Is a loop that happens at least one time. Okay? So if you want something to happen at least one time, like for example when the user is supposed to enter something, right? The user are always going to have to enter something at least one time, and then if it's bad, then you repeat and repeat and repeat, right? And that brings me to the, input validation business. Right? So let's say we have an int age, right? And the age is something the user is going to enter. So let's say we have bad age is less than 0 or bigger than 123. So I'm going to make my age bad to begin with, -1, right? That means you're born in the year 1 BC. Okay? And then you're going to go while age is less than 0 or age is greater than 123, I'm going to tell the user something like, invalid age, enter another one, or something like that, right? So I guess this is your input validation, which is make sure the user enters a good value for age, right? If it's a negative, maybe it's going to crash my program. If it's bigger than 123, we know nobody's that old, right? Whatever. So we're going to go with this, right? 123, I'm going to say invalid age, enter another value between 0 to 123, right? And then after that, I'm going to do one of these. Oh, no. It's going to be age is equal to SC, next int. Okay? And I'm going to run this thing. Zero, zero, zero. Okay, invalid age, enter a value between 0 to 123. Right? 999. No. Negative 789. No. 88. And then it stops. Okay, so that's your first example of an input validation. And another one is in here, I'm going to do, and by the way, if my age was good, let's say if my age was 10 here, right? And I run this thing, you're never going to see these messages, right? Because age is not less than 0 and it is not bigger than 123. The condition, the OR, is not true, so this loop is never going to happen. Okay? But now let's make another loop. And I'm going to do the same thing. I'm just going to grab this whole thing. I'm going to copy it, paste it in there. So this time we're going to have a good age. Right? Good age. If this was a good age, remember your conventional while loop, your regular while loop, is not going to happen, right? If I have it just like this, is this less than 0? No. Is it bigger than 123? No. So loop's not going to happen. But I can make it happen. All I got to do is I'm going to grab this here. I'm going to put it all the way at the end. I'm going to put a semicolon. That's the only time you're going to put a semicolon at the end of the loop, and I'm going to say do. Okay? So there you go. Even though it is a good age, right, I am still going to go through the loop at least one time because the condition is being checked at the end, right? So that's what the while loop is doing, a do while is doing. Okay? Throw that in there. All right? So this is a good age, but it gets checked at the end, so this loop is going to happen at least one time. I'm going to change this to this. All right? And then you're going to see that it works. 0, 0, 0, 0. Damn it. 99. Oh, that was that other one. All right. That was this one. Okay, so it happened. And if I entered a bad value for this one, then this one will repeat over and over and over again. Okay, and that brings me to the comment about semicolon, having a semicolon at the end of a loop. Do not put semicolons in any of these. Okay? Because unfortunately, Java, as smart as it is about initializing variables, it's not very smart about telling me an error.
Yeah, it's not going
when,
to be a message, right?
Yeah. So this is actually called a do nothing loop. If I went in there and I did this, it'll be the same thing as if you were to put a semicolon at the end of the loop. And the same thing applies to any of these other ones. If I put this semicolon in there, I am literally taking out the while loop. Okay, this time it gave me some kind of an error. Okay, here it's giving me an error. Right? If I take out the while loop, notice how it's complaining that break and continue, something about them. What's wrong with this? Why is it complaining about break and continue? There's no loop. You cannot have a break if you don't have a loop. You cannot have a continue if you don't have a loop. Okay? So that's that. Make sure no semicolons, not for the while loops, not for the for loops, right? Because remember, a lot of times it will not generate any kind of a compile error. This itself is not a compile time error. Okay, so it's always good to have compile time errors, except when it was that nonsense about the variable not being initialized. Okay, that's kind of annoying.
Yeah.
But whatever, we'll let Java slide. So that's basically it. In a nutshell, these are loops. You can have loops inside of other loops, but I'm not going to go there. Okay, so let's see if I miss anything in here. Yeah, I showed you that. So in exception handling, let me look at the exception handling. Yeah, we already saw some of this stuff. All right. But what you can do is you can generate loops around these exception errors, just like you did with Python, with the try catch thing. Very, very similar, so that you can, ask the user over and over and over again to, enter a good value, even if they accidentally crash your program, right? So you can tell that, okay, if it's one of these error messages, resume, continue, go back to the beginning, okay? But I'm not going to show you this for now. Maybe I'll update this example so that it uses these, so that it uses a loop.
Are you going to upload from the book like you did last week? That was
Huh?
helpful.
What's
Are you
that?
gonna upload from the book like you did last week?
Upload what?
Like when you
Sample programs and stuff? Oh yeah, I'll do that.
Super.
Yeah, I'll do that. From now on, I'm going to just keep updating all the chapters. So I have 6, 7, 8, 9, 10 left. All right, I'm halfway done. But then, no more book. We're good?
Yeah.
Okay, so if you have any questions, you know the drill. Send me emails. Come see me in the office hour. You have 5 assignments from chapter 6. I will update those so that you won't need the textbook. Just give me some time. I'll do it by the end of the week. So yeah, make sure you're keeping up with these. There's going to be, just so you know, if you go to the homepage, so we're already, you could say we're done with repetition. Next week we talk about strings, which is kind of an unusual place to talk about strings since we've been using strings all this time. But next time I teach the class, maybe I'll move things around. I'm just following the book as it is. Then we talk about arrays, right? I can tell you my arrays joke then. And then the week 9, we're starting to do something that you haven't seen before unless you did the calculator program in Python, which is graphical user interfaces, or GUIs. And that is, you're going to have dialog boxes and buttons and stuff like that. You actually already had a bunch of these, right, from chapter 1. But we're going to do a lot more things with them. Chapter 10, we're going to add more details to that. And then as soon as we get to chapter 10, I will assign your final project, and which is worth 15% of your grade. So if you do all of the assignments in this class without the final project, you get a B. It is the tic-tac-toe. Unless you want to do something else. Okay, you're welcome to, how'd you know it was a tic-tac-toe?
You look at the grades, scroll down.
Okay, good, yeah, it's tic-tac-toe, yeah. So, if you want to do a tic-tac-toe, there's, you can get the basic game of tic-tac-toe and make it as complicated as you want. The best one I had was last semester from this math major, and she wrote the whole thing in less than 300 lines of code, and it worked. And not just that, but it defended, it tried to beat you, and it tied with you all the time. I couldn't have done it in so little code, right? So the moral of the story is, if you take math, if you take lots of math, you become very good at programming, okay? But anyway, the final project is going to be that. So at the very least, you have to play it against yourself. You're going to have to use things that we learned about everything so far. So when we get to arrays, you're going to know about them. For the tic-tac-toe, you're going to have to use a 2D array, two-dimensional array, okay? Right, and at the very least, you can play it against yourself. If you want to make it more complicated, have the program try to defend against you, beating it first, and then after that, the next step will be to make it, try to beat you, And if you want to make it even more complicated, and you can make it an online game so that you can play against somebody on the internet. Nobody's taking it that far, okay? But if you do, I'll sing your praises in the future. So that's the game plan for the semester. So yeah, more fun things are coming. The final project, don't worry about it. I actually even have a video that shows you how to do the thing. Don't look at the video unless you absolutely get stuck. Yeah.
What's the Android one on the bottom?
Oh, Android. I will. Well, what do you know about Android? What's Android?
So, Windows,
Well, okay, tell me a little more.
Android OS,
Okay, Android OS.
Linux.
Okay, excellent. Android is Linux, and what are all the applications that are on Android written in? Java. It's all Java. Every app that's on Android is written in Java. It's not the same exact Java that we're using in this class. It's got its own different ways to get the whole thing started. It's slightly different, you'll see it, but in some ways it's actually easier. Yeah, but it's all Java. And 80-something% of the smartphone market share is Android. So if you learn Java, you can write apps for all these other ones, right? In fact, my first Android that I ever got was, you couldn't even turn on the flashlight app on the thing. So if you wanted to really turn on the flashlight on Android, you have to go and download an app, and the app would consume all your data because it will play a constant stream of advertisements on the bottom. Plus, I know that they were collecting data, so I said, well, why don't I write my own freaking Android app that turns on the flashlight? So I did. So those kind of things that you could do easily, once you learn some Java and play around with the Android assignment. It's not even an assignment. I just kind of show you how to do things. You don't have to do an Android. You could. In fact, if you don't want to do the final project tic-tac-toe and you want to do some final project with Android, I'm okay with that too. Okay? Just make sure you write it. Don't get your buddy to write it for you, because I'll tell. Okay? Yeah, so that's all. Oh, and use things that I show in this class. Unless, if you want to use something else I haven't shown in this class, I want to see comments. I want to see you explain to me how and why this thing is working. Anything that I haven't shown, that goes for Java. Okay? All right, so that's it. Come see me if you need help. Send me emails if you need help. And I'll upload this for you.